Okay, so the first thing we did was we subtracted the 42. So when you subtract the 42, this becomes negative 45. And then how do we find this 81?
Doing negative 18 divided by 2 squared.
Yep, negative 18 divided by 2 squared gives you a positive 81 on both sides. And then we factor this down. And this gives us x minus 9 squared equals 36. The square root of a number is positive and negative. You see where I said don't forget the plus minus? So x minus 9 equals positive 6. And x minus 9 equals negative 6. Add 9 to both sides. You get x equals 15 and x equals 3. Raise your hand if you had that. Okay, we getting there. I know completing the square is not our friend, but we're going to make it our friend. Tomorrow you have a very short skills check. There's only one question on completing the square, just one. Yeah. Let's see. Okay, so you factored it. So you did a different method. So if the directions say complete the square and you don't do it that way, you only get half the credit. Okay, so remember, there's 3 different ways to solve it. We could have factored it, we could have used the quadratic formula, or we could complete the square. You have to follow the direction because I need to see that you can do each method. Okay, so if you get the right answer by factoring, I'm proud of you. I'm gonna give you some points, but you don't get full credit because you didn't show that you understand the process of completing the square. All right, so now let's talk about Appendix 7. Appendix 7, if you're titling your notes, is complex numbers. So we're still in the back of the book. This can also be found on Canvas, so you don't need to write this down. This can also be found on Canvas. Right now, that homework is due Monday. I might end up pushing it back, but if I do, I'll tell you tomorrow. So for right now, homework for Appendix 7 is due on Monday. Keep that little red pen somewhere. Put it in your backpack and your purse so you'll have it again for Monday. All right, so let's talk about, first of all, what is a complex number? A complex number is when you have a real number and an imaginary number added together. And you don't really need to write this definition down. Okay? Just know that a complex number, it looks like this, and it's a real number added to an imaginary number. That's what a complex number is. Okay? So we're going to do some operations with complex numbers. So I'll give you a chance to write down. Go ahead and just copy down questions 1 and 2 because this won't take a lot of space. Now these 2 will take a little bit more space because they're multiplication. So take a minute and copy down examples 1 and 2. We'll work through them together and then we'll go through 3 and 4. So when we talk about operations, there's 4 operations: adding, subtracting, multiplying, and dividing. So we're going to start off by talking about adding and subtracting. Adding and subtracting, very, very simple. You're just combining your like terms. That's all you're going to do is combine your like terms. So for the first one is adding. So you're going to add together your real number. So this 2 and this 7. What do you get when you take 2 plus 7? 9. And then you're going to add together your imaginary numbers, negative 5i and positive 3i. So negative 5 plus 3 would be a negative 2i. And that is your answer. For question number 2 is subtraction. So what I like to do is distribute my negative first and then combine my like terms. So when I distribute the negative, I have 3 plus 11i, and then that negative 1 times 8 changes to a negative 8. And negative 1 times negative 4i is a positive 4i. All right, now you're going to combine your like terms. So your real numbers get added together and your imaginary numbers get added together. Whenever you write a complex number, we always write the real number first. So technically, if you were to write number 1 as negative 2i plus 9, I mean, I wouldn't mark it wrong, but it's just out of order. It's like the grammar, the math grammar is off. Okay, so for this number 2, when I add together 3 and negative 8, what do you get? What is 3 plus negative 8 or 3 minus 8? Negative 5. And now you're going to add together 11i and 14i. What do you get? 15i. And that is your answer. Any questions about 1 and 2? All right, let's look at number 3. How do I know number 3 is multiplication and not adding or subtracting? Because it won't say add, subtract, multiply. You have to look at the question and be able to identify what operation we're asking you to do. So how do I know number 3 is multiplication? Yep, the parentheses are touching. There's nothing in between. So I'm actually going to create a box. So when you create your box, some people FOIL, distribute. It's the same thing. But I actually do like the box for multiplying. I don't really care for it for factoring. But for multiplying, I do. Wait. So 3 plus 4i. And negative 2 minus 5i. Let's go ahead and fill in our 4 squares. So we have the negative 2 times 3, which is negative 6. Negative 2 times 4i is negative 8i. Negative 5i times 3 is negative 15i. So now let's talk about this 4th square. I'm going to do this one off to the side. Well, I'm going to try to fit it in here, actually. When you multiply negative 5i times 4i, you get negative 20i squared. But we cannot leave I squared. Does anyone remember what I squared equals? Not 1.
Oh, it's
Negative 1. I squared, this is your first rule. Go ahead and write this down if you don't remember it. I squared equals negative 1. That's important. So anytime we come across an I squared, we have to automatically change that to a negative 1. So in this box, what I really have is negative 20 times negative 1. And what is negative 20 times negative 1? Positive 20. So I really have a positive 20 in this box. So you're ready to combine your like terms. You're going to add these two together. We're going to start with our real numbers. So because I changed that to a negative 1, now that bottom right corner is no longer imaginary. It's a real number. So go ahead and add negative 6 plus 20. And negative 6 plus 20 gives you what? What does it give you? 14, yep. And then negative 15i and negative 8i, they're like terms. So negative 15 plus negative 8 is negative 23i. And that would be your answer. That's what you get when you multiply it. All right, I'm going to zoom out. I want you all to try to do number 4 by yourself. Make a box and simplify it. You do not. If you want to distribute foil, you can do it that way also. Oh. Okay, see if you all agree with my answer. All right, who had that? All right, any questions about how to, so now we've already done 3 of the operations. We added, we subtracted, and we multiplied. So now let's go to the last one, which, what do you think that would be? After add, subtract, multiply, the 4th one would be divide. So let's divide and then we'll end there. Okay, so the thing about division is that, I'm gonna write this rule. You cannot leave I in the denominator. So when we do division, we're really just simplifying it so that we don't have an I in our denominator. So we have these 3 fractions and they all have I in the denominator. The only way to eliminate the I is to multiply by the conjugate. So conjugate is a fancy word, but all that means is change the middle sign of your denominator. All right. So for number 6, if I want to get rid of this I, and this is a binomial, there's 2 terms, I need to flip that middle sign and multiply top and bottom by that. So I'm going to multiply this fraction by 1 minus I, top and bottom. All right, so for the numerator, I'm going to abbreviate that. You're going to multiply 6 minus I times 1 minus I. Go ahead and make a box or multiply it any way you know how. So we're multiplying by the conjugate in order to get rid of the I, because we can't leave I in our denominator. So that will give us a positive 6, a negative I, a negative 6I, and then this last square we have a positive I squared. And what does I squared equal again? So that's really a negative 1 in that box. So my final answer, we're going to add these two, and we're going to add these two. So I have a positive 5 minus 7I. That's my numerator for my answer. So I'm going to put that in the parking lot and come back to that later. Let's talk about the denominator. When you multiply two conjugates, the middle term always cancels out. So I'm going to do it the long way. So for my denominator, I'm multiplying 1 plus I times 1 minus I. Go ahead and make a box and multiply that out. So that'll be a 1, a I, a negative I, and this is a negative I squared. So negative I squared means I'm taking negative 1 times I squared, which ends up being negative 1 times negative 1. So what do I really have in this fourth box? A positive 1. Okay, so this is always going to happen when we multiply two conjugates. Because remember, the reason why we're doing this is to get rid of I. And anytime you multiply two conjugates, the I's will cancel. So those cancel out because negative I plus I is 0. So when we add these two together, we have 1 plus 1, which is 2. So my final answer, if I go back to the top box, is this over 2. That would be my answer. That's what I get when I divide it. Can I simplify that? Is there a number that goes into 5, 7, and 2?
No.
Nope. So we're going to leave it like that. This is the answer. This is what you get when you divide. Any questions? All right. Couple more, and then we are done. So for number 6, I'm multiplying by the conjugate. Well, this is what we call a monomial. So I'm really just multiplying it by positive 2i. So I'm going to multiply this by 2i, top and bottom by 2i. We don't need to make a box because it's only one term being multiplied. So I can just distribute it. So for my numerator, I have 2i times 2 minus I. Let's go ahead and distribute that. And that's going to give me 4i minus I squared. Oh, sorry. 4i minus what? What's 2i times I? 2i squared. There we go. So 2i times 2 is 4i. 2i times negative I is negative 2i squared. So then we have 4i minus 2. And then that I squared is really a negative 1. So I'm left with 4i plus 2. Now let's do our denominator. So let's multiply negative 2i times positive 2i. What do you think we're going to get there when we multiply that together? Negative 4i squared, which is negative 4 times negative 1, which is positive 4. So we're going to put these together. So this is the numerator and this is my denominator. So let's put it together and make it one fraction. So my answer is 4i plus 2 divided by 4. Now this time though, we can reduce it. When I'm looking at these three numbers, what number goes into all three of those terms? 2. And really, I'm not going to be this picky on the test. This should be written as 2 plus 4i instead of 4i plus 2, but I'm not going to be picky about that. We're okay. We're okay. But we do need to reduce it. So let's divide those numbers by 2. And my final answer would be 2i plus 1 over 2. And notice that I always try to make my I not look like a 1. So I always make my I like curve a little bit. Make sure it's dotted. All right, we only got one more question and then we are done for today. Go ahead and copy down this last one. I got to give myself some space on the right. Hold on. Okay. All right, go ahead and copy down this last one. So what do you think I'm going to multiply by? Because I have to get rid of this. So what am I going to change this to? 5 plus 12i, top and bottom. We're going to multiply it by 5 plus 12i. So let's start with the numerator. Go ahead, take 13 times 5 plus 12i. Go ahead and distribute that 13, see what you get. And then I'm going to show you the shortcut for the denominator. Because if we're multiplying two conjugates, we don't need to make a box. We're going to do it the shorter way. I'm going to show you the shortcut, but if it confuses you then make a box every time. So 13 times 5 is 65. And somebody remind me, what's 13 times 12? 156. I. All right, so I'm going to leave that like that. We're going to leave that in the parking lot, come back to it. Let's look at our denominator. For our denominator, because I'm multiplying two conjugates, I already know that that middle term is going to cancel. So the shortcut would be to just multiply these two together and multiply these two together. Okay? Because the two middle terms are going to cancel out. So if I take 5 times 5, what is 5 times 5? 25. And now take negative 12i times positive 12i. Negative 144 I squared. Now that I squared is going to change to a negative 1. So when you type that in your calculator, 25 minus 144 times negative 1. Yep, 25 plus 144, which is going to give you what? 169. Who got 169? All right. Again, you only do this shortcut when it's two conjugates. You don't need to make a box. So now let's go ahead and marry these two together. So I have 65 plus 156I over 169. That's my answer. But this can actually reduce, though. Now, I would take that. I would only take off a half a point. We're still winning here. But there is a number that exists that goes into all three of these numbers. Does anyone recognize what that number would be? 13. Go ahead and divide these three numbers by 13. A7 is really short, so that's why, I mean, we're going to finish it tomorrow. It's not a whole lot in A7. A6 was long. It was a lot of stuff in A6. A7, we already halfway done. We only got one more thing to do. I could try to squeeze it in today, but no, we'll just do it tomorrow. All right, so when we take 65 divided by 13, we get 5 plus 12I over what? 13. This is the answer that gives you full credit. All right, good work today, y'all. Yes, Daniel.